Okay, so 3, 2, 1, I'm pressing go live button.
So the other thing they talked about, so not only was it like these two college brothers basically started Pizza Hut, they then went on and then
We're live.
they talked about the guys who started Domino's. It was really, really cool. So,
Okay.
hey, everybody, welcome to SolidWorks Live Design. We're going to get started here in about 3 minutes. Me and Toby, we're just going to chat and hang out with you all here for a few minutes before we get started. Hey, Toby, how's it going?
Oh man, it's going so good, Jeremy. Thank you so much for having me here. I can't believe it. We're doing live design season 2, essentially, right? Season
Yeah.
2021.
Yeah, it's going to be cool. I can't wait to get started here in a few minutes. So Toby, I wanted to ask you a couple questions really quick. I had done it in the beginning. I noticed you have the Stream Deck in the back. Now, some people are going to be tuning in. They may not know this. You actually like run a YouTube show on Monday nights, right?
I do, Jeremy. Well, I used to. It actually this season we're experimenting a little. We're running it on Saturdays this season, but yeah, I run like it's kind of like tips and tricks, kind of like current news, but probably the thing that'll be closest to your heart, a weekly 3D CAD modeling competition. Just a little friendly competition, no prizes or anything, just bragging rights. But it's a lot of fun. If you did Model Mania, which I know you've won Model Mania, right? Once,
Yeah.
twice?
Twice I have.
Wow,
Yep.
That's awesome, man. Yeah, if you like Model Mania, you'll like these kinds of challenges where I show you a 2D print and you can turn it into a 3D model. I know there's a lot of people in the chat here. I see Ray is here, Ed is here. I see Cam is here. These are all people who are regulars on that chat as well.
All right. Yeah. So Cam, Legrand, Ed, hi to you as well. We're going to get started here in just a couple minutes. We're just hanging out, chatting for a few minutes before 11 a.m. Eastern time. We thought we'd not surprise anybody by coming on live and then just kicking things off. So
you said that you can the Stream Deck, like I use the Stream Deck when I'm live to kind of change out what scene I'm doing. Like if I'm interviewing somebody, I'll change it from two, both of us together to just one person sharing their screen. But you said you can use that for SolidWorks as well?
Yeah, you can use it. So I've been researching it. So we do a lot of video work. I've been using it for Premiere Pro, After Effects, Audition, but you can use it for any program that you can assign a hotkey. So think about that. That thing's 15 keys. Every key can go into a folder.
Yep.
You could literally be like, I'm just going to hotkey everything. And what's cool,
every icon.
People who might not know how that thing works, you actually can have the icons right on there, which is super cool.
Yeah, that would be cool. Yeah. Every little button on there you can customize and turn it into whatever icon you want. So I could totally see that being helpful in SolidWorks, where I could just have like every little icon on there that I ever use.
Yeah. Hey, Sash, welcome to SolidWorks Live Design. We're excited to have all you guys here too. Let's go like one more minute, Toby. Just give people time to jump on so they don't miss any of the stuff at the beginning.
Yeah, for sure.
Does that sound good?
Yeah, absolutely. So, Jeremy, what's your favorite feature in SolidWorks?
Whoa, I wasn't ready for that. My favorite feature in I think, I think it's, to be honest,
I like seeing you think through all the different features. Like I can actually see
it. It's you know what it is? It's not necessarily like a feature so much as it is a UI element. It's command search. And if you tuned into 3D Experience World virtually 2 weeks ago, we showed the tech preview. Crazy, it's moving to the shortcut bar. I'm like so excited for that.
I can't be right there.
Yeah,
it's gonna be right there in the S key.
Yep.
I do love the S key myself, but I'd say probably my favorite feature, fit spline.
What's that? Fit spline?
Fit spline. I gotta say, man, that's one that has gotten me out of so many jams and helped me out so much over the years. I love it. From a UI perspective, S key hands down. S key is my favorite thing about SolidWorks overall.
Yeah.
But features, like a specific feature, fit spline.
Let's ask the audience the same question. So audience, tell us what's your favorite feature in SolidWorks, and while you guys are answering, we're going to go ahead and get started. Does that sound like a good plan, Toby?
Yeah, good call. I see people already saying their favorite feature. South TTM, Brad, what's up, Brad? Says with mate. Yeah, that's a good one too.
Yeah.
And Vibaf says Weldments, yes, I love weldments as well. And Tony says, stop talking and resolve problems. I
Let's
like
do
that.
that.
He just wants to get into it. So I like it.
So I want to welcome everybody to the first episode of SolidWorks Live Design in 2021. This is we're rethinking what this series is going to look like, kind of moving forward. So you've got a host, a guy like me. I'm Jeremy Rigneris. I'm normally on SolidWorks Live, but we're going to have different hosts on this show. And then we have a presenter. I'd like to welcome our very first presenter, Toby Schnarr. Welcome to SolidWorks Live Design.
Thank you. Thank you for having me. Excited to be here.
So, Toby, we were thinking, what would be a good way to kick this off? What would be something cool that the audience would really dig that we could get into?
Yeah, I mean, there's so much that we can choose from, but I thought that a great topic for this, to kind of kick things off would be to talk about patterns. Patterns are something that, I mean, you and I were brainstorming it, right? We were like, we could talk about this, we could talk about that. But when you said, you were the one who suggested it. When you said patterns, I was like, yeah, that's a great suggestion. Let's do that. Yeah.
Yeah, it's this super powerful part of SolidWorks that it doesn't actually build the initial geometry, but what it does is it greatly reduces the time you spend creating repetitive geometry.
Yeah. I mean, and there's so much that you can do with regards to really diving into some of these patterns. So I think I'm just going to show my screen here, and we can kind of talk about where this brainstorming went as far as, first we decided, okay, we're going to show patterns. Well, what does that actually entail? Because there's so much to choose from. And so I kind of refined this presentation to call it Secrets of Patterns. And so when it comes to secrets of patterns, what I really wanted to do is just kind of dive into specific areas of really a lot of it is linear pattern and also circular pattern. Now, why did we refine it down to just that small amount? Well, if we look at all the different available types of patterns, there are so many. I mean, even in sketch mode, you can create a pattern. So you could sketch a circle, and then you could do a circular pattern or a linear pattern of that circle. Do you ever use that one, sketch pattern?
So I have to admit, I'm not the biggest fan of sketch patterns. I'm always create my sketches as simple as possible, and then I use feature patterns to duplicate that geometry. I just feel like I would prefer to derive things with features as opposed to sketches.
Same exact way. You keep your sketches simple, right? That's what I always try to do. And if you're creating a pattern inside of a sketch, you're going to end up with a lot of individual entities you're going to have to manage, and that can sometimes kind of become a tangled mess. So when it comes to feature patterns, man, we got so many of them. Looking at these icons here, you got the fill pattern in the upper left. Below that, you've got the mirror pattern. Then in the next column, you've got the circular feature pattern, linear feature pattern, point-driven sketch feature pattern. You've got the table feature pattern, the curve-driven feature pattern, and even the newer variable pattern at the feature level. And I mean, if we take a look at all these patterns, well, you basically have the same amount of pattern types available at the assembly level. And you could even do patterns at the note level.
This is bonkers. I mean, patterns are everywhere inside of SolidWorks.
Yeah, I mean, of all these choices, what do you think is your favorite type of pattern, Jeremy?
So I'm gonna pick two. I'm like that parent with multiple kids. I can't ever pick one favorite. So I'd have to say at the feature level, sketch-driven patterns by far and away I find to be super useful for those niche cases. At the assembly level, derived pattern. I like patterning components based on an existing pattern, putting that design intent into my design. So those are my favorites. Toby, what is your favorite pattern?
Yeah, I mean, I think those are both really good choices. I think for me, my favorite type of pattern, probably sheet metal flat pattern.
Toby, I don't think that's how patterns, how they work here.
That's my little joke for the day. Hope you guys all enjoyed that. Let's get into it here. Let's talk about secrets of patterns. So what we're going to do here is we're going to jump into a couple of different topics. We're going to start out by talking about how when you're in a linear pattern, you can actually drop equations right into that linear pattern. But maybe there's an easier way to do it inside a linear pattern. We're going to talk about geometry pattern. Maybe you've gotten this error before, feature pattern failed to create. Try using geometry pattern. What the heck does that mean, right? Maybe we after that we'll have some time to talk about the very sketch option, which is super powerful inside a linear pattern. And And then we're also going to talk about the similar but slightly different vary instance option inside of different types of patterns. So that's kind of our loose agenda here. I'm going to jump into SolidWorks Connected, and we're going to take a look at our first example here, which is an example of doing a linear pattern where our goal here is to create kind of equal spacing from the end of the part to this first hole and the other end of the part to this last hole, and to have that value derived from the distance between these holes and the number of holes themselves. So we're taking really, actually, I should say kind of the overall length and the number of holes itself. So we're going to take the overall length of this part. We're going to divide it by the number of holes. That's going to kind of give us some equal spacing. But we also want that to incorporate the distance from the end of the plate. We want that to be uniform. We want the distance off of each end to be the same. So I'm just going to start a new part here in SolidWorks Connected 2021. And from this new part, what I'm going to do is I'm going to jump into a top plane, begin a sketch, orient my view, pretty much the same workflow every time, right? Select a plane, begin a sketch, orient your view. Now, of course, when you're using SolidWorks, one of my favorite things is to use auto dimensioning. So I'm going to make this 30 by, 160. I'm kind of shooting from the hip here a little bit, Jeremy, okay? So we're going to take this guy here and make it midpoint, and then I'm just going to take, you know what, I'm going to be doing equations here. Now, I know I've watched a lot of your presentations on doing equations, and one of the tips that you've given that I think is really good is that when you're working with equations, what you can do is you can rename your dimensions. So I'm going to make sure that Instant 2D is not turned on, because if Instant 2D is turned on, I click on the dimension, it's going to put me into an edit function. So Instant 2D is not turned on, and then I'm going to click on that dimension. I'm going to come over here, and I'm going to call this dimension width. So that's the width of the plate.
So Toby, can I show you a pro tip here that you can do while Instant 2D is on? I don't mean to like detract from what you're showing.
Please.
Go ahead and do that. Turn on Instant 2D.
Okay.
Quickly double click on that dimension. Quickly.
Yep.
See, you can still name the dimension up there in the modified dimension dialog box. So that's a tip for people watching. Yes, you can do it in the property manager, but you can do it right there too.
Yeah, you don't even have to go over to the property manager. I'm still going to turn off Instant 2D because I got beef with Instant 2D for other reasons, but
sure,
we can talk about those in another presentation. And then I'm going to take this this rectangular plate here, and I'm going to do a reverse direction and bring that down. And then I'm going to go to the upper surface there, begin a sketch, orient my view, maybe make a diameter circle here of 15 millimeters. We're going to set that up so it's right in line with this existing origin, which is at the center of the part. And then we're going to create another dimension here that comes across. And I'm going to say that's going to be, I don't know, let's make that 22 millimeters. And now that I learned that new pro tip from you, maybe I'll press my luck a little bit and I'll call this one offset, because that's the offset from the end right inside of that dialog box.
Yeah,
that looks pretty good.
Hey, I want to, while you're working on that, Toby, I just want to give a shout out to the chat. If you've got any questions for Toby while we're working along, make sure you throw those in the chat right here in YouTube. I'm watching. That's why I'm here. I'm going to be watching the chat. And if any questions come up for Toby, we'll make sure that he gets those questions to him. By the way, Toby, Eric Beatty's in the chat. He says, dare I say at Too Tall Toby, am I starting to see a pattern here?
Well, shout out to Eric Beatty. He's always in the live streams.
Yeah.
Super power user. I see a pattern of Eric Beatty all over 3D Experience World this year.
Yes,
man, you were all over the place. That was awesome. So, all right. So we got our first hole here in this model. I'm going to just kind of close this this property manager, its task pane over here. Now, what this task pane is doing over here is it's just giving me some additional access to maybe some additional tools. But I think for now, I could probably just kind of minimize that so that we can keep going here on this first example. So what we're going to do with this first example now is we're going to take this hole and we're going to do a linear pattern. So we're going to go here, features, linear pattern, and we're going to say it's going to run along this edge, and the feature that we're going to pattern is going to be this hole, and we'll say maybe this is going to be 25 millimeters for the spacing. All right, that looks pretty good, right? Kind of gets us started, but we didn't incorporate any of that cool functionality we were going to talk about, right? So let's say we're going to go to the number of instances here in our pattern, and we're going to go to the spacing in our pattern. And just like we did before, we can rename them either over in the property manager, or we could rename them by double clicking on the dimension. Shout out to Jeremy for showing me that tip. So this would be number of holes. And you can see here that now we can double click on the spacing, and we can say, instead of this being 25, we're just going to type the equals number on our keyboard. And we can come down here and we can single click on this plate. and we can single click on this dimension. And now the spacing in that pattern is going to equal the width of the plate. Well, that's not exactly what we want. So let's type the little slashy here for divide. And then we're going to click on the feature that represents the linear pattern. And we're going to click on the dimension that represents the number of instances. And so now we can see that the spacing of the holes is going to be derived from the overall width of the plate divided by the number of instances in the pattern. So we hit the green check mark and we rebuild, and wow, that's amazing. Look at that. It's automatically updating that spacing. If we change the width of the plate, it's going to automatically update. And at first glance, it kind of looks like it's good, but upon further inspection, what you'll start to realize, and you can kind of even see this in the results here, is that the spacing from the end of the plate is not quite correct. So, for example, if I was to change this to 7 instances, we want that spacing from the end of the plate to be the same. One way that you could kind of quickly see this is you could go into your measure command. So I'm just going to go S key, and I've actually added measure to the S key. And then I'm going to click this circle here and click this edge. And we can see that offset is 10.4 millimeters, 10.14 millimeters, when it's supposed to be, whatever we created on this end. So the actual equation that we have to put in there is a little bit difficult, not super difficult, but it's a little bit difficult, right? Basically, what we need to do is we need to say that we want this distance here and this distance here to be subtracted from the overall plate. So we want to take this overall width here, and then we want to subtract 2 times this distance. Let's say it's 2 times x. So we want to take the overall width and subtract 2 times x, and then we want to divide that by the number of holes, but we want to eliminate one of the instances of the holes because the first instance of the hole is already accounted for with that initial offset sketch. So the equation starts to become a little bit cumbersome. It ultimately ends up looking something like this. This spacing here that we're trying to auto-calculate is going to equal, and then we'll do parentheses here, is going to equal the width of the plate minus the original offset distance. So this original offset distance here times 2, because we want it to be offset from both sides. We want it to be the same. And then that's going to be divided by the number of holes. And I'll do another parentheses here, and I'll do minus 1 and then another parentheses. And we'll see if we got it correct. Looks like my syntax is off a little bit there.
So this sounds kind of hard what you're doing right now, Toby. This is a lot of work to put this.
It's a lot of work. Together. It's a lot of work, man. In fact, I'm gonna cancel out because you're gonna sit there. You're gonna be trying to get it to work, and ultimately you might run into kind of similar issues here where it just ultimately doesn't work for you, or you just can't get it, or it's just you're spending quite a bit of time trying to figure out like what is it that I'm missing, what step am I missing. So instead here, what we can see is that if we go into the linear pattern command and we say that we're going to linear pattern from this edge here and we're going to linear pattern this feature, we could actually go right up here into the linear pattern dialog box. And in the linear pattern dialog box, there's this option for up to reference. And so what happens is instead of having a distance between each instance and a number of instances, what you end up with here is you end up with what's the reference that you want to go up to? Well, I want to go up to this final face here. And then you get this option down here for, do you want to have equal spacing between the holes, or do you want to have a total number of holes and then automatically let Solidworks calculate the spacing between them, which is the exact equation I was just sitting there struggling with, couldn't get the syntax right, didn't know what the equation was, didn't know what I was missing. On top of this, you can even do an offset. So you can see here that I could say I want this to be offset 35 millimeters from the end. So now this distance here from the end to this hole is going to be 35. And it doesn't look like 35 was right. And I can't remember what the original dimension was that I used. Well, we can go right into this dialog box and type equal. And then we can come out here and click on that first instance and get its dimensions to show up. And we can click on that dimension that represents that first instance. So let me just make that 35 for now. It's the dimension's not showing up, so I'm going to just leave it at 35, and then I'm going to double click on that linear pattern. I'm going to double click on this dimension here. I'm going to type equals, and then I'm going to click over here on the first feature, and I'm going to click on this dimension. So my offset equals, my offset from this end over here is now set up with an equation to equal my original offset from this end here. So I'm going to hit the green check mark. Rebuild, boom, good to go. So cool, right?
This is so easy. So this was like a stealthy little feature that got added. I don't remember. It's probably been within the last 4 releases, I want to say, maybe 5. I can't remember. I remember when this came out going, every machine designer who has to build a block with like equal space holes on it is going to love this thing.
It works so good. I mean, it's like you said, it's kind of one of these things that's just been added into the software. Maybe you didn't realize that it was added here, and you can see here that what we end up with is just right in this dialog box, this little tiny addition here, this up to reference that makes all the difference and can really simplify your life.
All right. So, Toby, we're going to jump over to chat here really quick.
Sure.
There's a lot going on. Again, if you're watching right now, you have questions for Toby, throw those in the chat, especially if it relates to any of this pattern stuff. I see a lot of cool conversations. Looks like we have a veteran in there looking for a way to learn SolidWorks. He's gotten a lot of great answers. So anybody tuning in at a later date, definitely go check that out. Watch the comments there. They're showing that student edition is available for them, and there are resources to learn SolidWorks on mysolidworks.com. Really, really cool resources there to go and understand that. So Toby, that was really cool how you were showing how you could use the equations to drive that pattern. But what I really liked was the fact that you showed how to do that up to reference. That's like one of my favorite things in a pattern. That's that's definitely one of the secrets of patterns. What else do you have for us?
It's so cool how it works out, right?
Yeah.
So I think at this point, what I'm going to do is I'm going to jump into the geometry pattern discussion, because we've all gotten this error before where it comes to geometry pattern, and we're trying to just kind of figure out like what exactly is happening there with geometry pattern. Why are we running into that error with geometry pattern? And so what we're going to see here is that when it comes to geometry pattern in SolidWorks, we can, the reason that error shows up, the challenge that you run into, if you will, when that error shows up.
Can we show that error so people
sure
can
yeah
see
let me
what
open
we're
up
talking about?
Absolutely, yeah. Let me open up a file here. You can see this file is coming in and read only because I'm actually managing this with data management in the cloud, and so somebody else maybe is working on this file, and so I'm kind of being blocked from making changes, but we can still definitely take a look at what that error looks like. And then maybe in a little bit I'll take control of this file. I'll reserve this file so I can start making changes, because I think I got some revisions coming up for this file. So you can see that the anatomy of this file, the way that this file was created, was that it started out with this kind of main base shape. And then as I roll forward in the tree here, we have this little set of divider slots and then these upper pockets. Now, the offset on these upper pockets is a little bit different. And so that's why, I didn't include that in what ultimately will be my linear pattern feature. And so I'm going to roll forward here, and I've created this inner pocket, and then I created a half circle boss here, and then I created some little fillets here on the corner. And my goal is to take this geometry down and lay it into all these other pockets. And so I'm going to jump into the linear pattern command, and I'm going to click on this little edge here. I'm going to specify my spacing. So I'll say that my spacing here is 50 millimeters, and there's 4 instances. And I'm going to come down here to my features and faces, and then I'm going to choose those features, maybe from the graphics area or maybe from the tree. Either way, I can get those features. Ooh, my pattern preview looked like it was there at first, and then it kind of went away.
Yeah, what happened with that?
I don't know. It's weird. When I click full preview, it goes away, but when I click partial preview, it's there. So I don't know. It'll probably work, right? So we'll hope that partial preview fixes it. So we'll hit the green check mark here, and when we hit the green check mark, we see rebuild errors. The vertex used to define the vertex end condition is not in the model. Please use edit definition to specify the vertex. And a lot of times what you'll see is kind of a similar error here, where you'll see something like pattern failed to create, try to use geometry pattern. Like in this example here, if I wanted to take the spoke here and create a circular pattern of the spoke. So I'm going to do a circular pattern here. Let me go before I put that hole in the middle. We'll do a circular pattern here of this spoke. And from the circular pattern here, we're going to say we want this to be equal spacing, and we hit the green check mark. And it says, pattern for sweep with guide curves is not currently supported without the geometry pattern option. Try using geometry pattern option. Now, believe it or not, both of these errors, even though they're saying something slightly different, the culprit in both of these errors is the same thing. And the culprit is the idea of geometry pattern, which is really a derivative of the idea of a pattern tries to solve for end conditions dynamically. And what that means, and really how you can visualize that pretty easily, like if you're talking to a coworker and you're trying to explain this, what you could do is you could create a set of geometry that has some kind of a unique topology. Usually I'll do something like this. Like I'll create a little spline here off the top of a thin feature extrusion. And you can see that I can bring out that thin feature extrusion like so. And then what I'll do is I'll pick this face and begin a sketch of a circle, and I'll extrude that circle up with a dynamic end condition. So what I mean is something like an offset from surface. So I'll go offset from surface here, and I'll pick this face right here. And there we can see our extrusion going up. Let's say we're going to bring that off 50 thou from that surface. Now we're going to create a linear pattern of that boss extrude. So we go to create a linear pattern of this boss extrude. We say we're going to go in direction 1 here. We say that we're going to use this boss extrude as the feature. And we say we want our spacing to be, say, 1/4 inch. Looks like a pretty cool pattern. I'm going to hit the green check mark, and whoa, that's kind of cool.
That's awesome, Toby, that it will like follow that surface on every instance.
Exactly. The end condition, the dynamic end condition is solved throughout the duration of the pattern. So this instance is doing offset from surface. So is this one. So is this one. So is this one. So that's beautiful unless this spline doesn't extend out far enough. When that spline doesn't extend out far enough, that's when you start running into issues. So for example, if I was to kind of dial this spline back a little bit here, like so, let's see what happens to our pattern. Uh-oh.
Oh.
The end face cannot terminate the extruded feature. Please recreate the feature using the geometry pattern option if intended to mirror pattern the feature onto disjoint bodies. So you'll notice here that over the years, the team at Solidworks has done a great job of kind of trying to give you a variety of dialog boxes that will maybe help you to decipher what's going on with this error. But ultimately, they're all saying the same thing. You've got some kind of a dynamic feature in your base feature, and it can't solve in the patterned location. That might be that you're doing a fillet and the faces that you're trying to fillet onto don't exist in the new location. It might be an up to surface or an up to vertex, and that vertex doesn't exist in the new location. You know, there's a number of reasons why this might happen. But ultimately, what you'll see is if you go into the edit feature command on that pattern and you choose the option for geometry pattern, what you get is an exact duplicate of the original. And so this is why you will see that suggestion often, and this is kind of how you can work around it and what the result is of working around it. So if we return to maybe the spoke example, and we go to create our circular pattern of the spoked features. So we got our spoke sweep, our spoke fillet 2, and then we've got our direction 1 right here. And this time we're going to say, let's do this with geometry pattern. We hit the green check mark. Hey, it worked. And if we go to our extrusion here, I mean, really, I think a lot of times it's not only important to see that it works, but maybe even to dive in a little bit and try to figure out why it worked. In the case of this feature here with the half circle boss, the dynamic end condition of this half circle boss is to go up to vertex, up to this vertex right here. So I'm boss extruding from this location in direction 1, which is a polarized direction. It's in this case, it's positive X. I'm going in direction 1 in positive X, and I'm ending up at this vertex here. Well, I mean, you can kind of ask yourself, if you had a circle here that was extruding in positive X, would it be able to terminate at this vertex here? No, right? It's not going to be able to go positive X and like loop around and end up at that vertex. So that's why you end up getting that fail when you do the pattern. But ultimately, what we can see is if we attempt to do the pattern again, and we use that option for geometry pattern, so we're going to say this is going to be our direction, and we're going to say this is going to be our distance, 50, and we'll make this 4 instances, and we'll say geometry pattern on, hit the green check mark. Beautiful. It works. We're golden.
Toby, that's great. I think there's a few caveats we should probably tell the audience about with this, though. So, like, let's be really clear. When you use geometry pattern, all you are patterning is just the identical geometry you created. So if you wanted some form of intelligence in there, you really want to understand in your example that up to vertex. Is there a better way to maybe define that feature to get it to maintain that it's intelligent as it's moving on?
That's a great point, Jeremy, because you know what can happen sometimes is that, let's say I do something similar here, but this time I'm going to start at this face. So I'm going to start at this face here, and I'm going to say I want to make a circle, and I want to extrude it, and I'm going to make the end condition up to surface. So I'll just double click on this surface. You'll notice over here that automatically changed the dynamic end condition to up to surface on this face here. And so now we're going to hit the green check mark, and we're going to create a linear pattern of that. So I'm going to do linear pattern in direction 1 with this as the feature. Same as before, right? 4 instances, geometry pattern not enabled. Well, what's going to happen here? Each of these pattern instances is going to try to go up to surface and go up to that same surface. And so I end up with something like this. Kind of weird, right? Maybe not what you would expect, but a great illustration of how geometry pattern works. And this is an opportunity to say, oh, maybe it would have been better if I would have just done that blind rather than trying to make it dynamic. Or maybe it would have been better if I would have done geometry pattern to make sure that the copy is identical rather than trying to dynamically solve. So even here, even though I didn't get an error, geometry pattern could still be the best solution. In this case, it's saying I can't geometry pattern this anyway because of another criteria that's missing on that one. Ultimately, I think it's this face here not being present. So, but yeah, I mean that's another another good one to know about is that the use of that dynamic end condition. Sometimes you just end up turning it off, even though you're not getting an error, just because you're not getting the geometry that you want.
So hey, I want a quick jump here into chat. We've had they're really digging all the pattern stuff, but there's been a couple questions about visualize. So I want to give you a heads up. So I should have probably mentioned this at the beginning. SolidWorks Live Design is going to be every other Thursday at 11 a.m. Eastern Time. So right now we're looking at May 20th. We actually have a session scheduled with the man Mike Sandy, the expert at SolidWorks with SolidWorks Visualize. He's gonna be rendering that awesome DTV shredder vehicle that you may have seen pop up online recently. And then one other question I want to jump into here. Michael Steves, one of the guys who will be on here next week, actually points out that geometry pattern can also help improve the performance with this option using performance evaluation. So.
Yeah, that's a great point. I noticed that as well. I mean, this is always a great tool to know about. So you find this tool here on the evaluate toolbar. So you can see here, I went to the evaluate toolbar and I went to performance evaluation. And this is, these are the kinds of questions that we often get. It'll be things like, which is faster, doing it as a sketch pattern or doing it as a feature pattern? Which is faster, doing a cut extrude or doing a shell? And this is where you can go to answer that question, right? You could create your pattern using the geometry pattern option off, and then you could create the pattern using the geometry pattern on, and you're going to see here what the solve time is for that feature. And so you can also kind of find out those questions, find out the answers to those questions, which is faster. And Michael makes a great point. When you're creating a pattern, this is something that we talked about a lot in Essentials too. Like if let's say you've got a perforated board and you're going to have 1,000 instances of a rectangular cut extrude. Well, you could make that cut extrude blind, or you could make that cut extrude up to next or up to vertex, something like that. Well, as you guys just learned, every instance of that 1,000 instance pattern is going to try to solve for that up to next or up to surface. And that's going to make for a much longer rebuild time than if you had just made that feature blind. Now, what Michael Steves is pointing out here, which is another great point, is the other thing you could do is make the first one through all or up to surface or up to next. And then you could do geometry pattern. And again, that way each copy is kind of a dumb copy or a non-dynamic copy. Yeah. I should say it that way.
So I want to address, I've seen this question come up twice, and I don't know that. I think there might be a bit of a language barrier here. Maybe, Toby, you could help me decipher this. I've seen, how can you populate a sketch by a part? And I think maybe the language or the wording here is a bit challenging. So, Albin, I'd ask maybe if there's a way you can re-ask that question, maybe we can address it. Or Toby, do you maybe know what he's referring to there?
I don't know.
Okay. So yeah, Albin, maybe if there's a way you can rephrase that question, we could ideally address that.
Cool. Yeah. Yeah. And I see also Deepak was asking if there's a repeat command tool. I mean, that's always a good one to remind people about. You'll see here if I go to the fillet command, let's say I'm going to do just a regular, edge fillet here. And so I'll click on this edge here, and then I press enter to finish the command. But then if you press enter again, that takes you back into your recent, most recently used previous command. So repeat command is just enter. Always a good one to know about if you're doing a lot. I do that a lot with delete face. So like I'll do delete face and delete like 4 faces, finish the command, then just press enter again, delete face again. Because a lot of times when you delete, it deletes and patches, and then you have that patch region which you're using to construct the next delete. So always good to know that you can repeat that.
Hey, Toby, so there was it's not so much as it's a bit rhetorical. Can we look at where did you find that performance evaluation again? So I want to reiterate, like this is a cool tool here. So let's show everybody where they can find this.
Yep. So you go to the evaluate toolbar. Oops, I almost circled the wrong one. And then you go to performance evaluation. So it's, you could go tools evaluate, or you could go to the evaluate toolbar, and then it's called performance evaluation.
This is a great tool. It helps you find out, like if you have a part that's, running slow, this is a good tool to help you diagnose what features may be having an impact on it. In assemblies, you can leverage this tool in the same way. You can find out like what parts are really slowing things down. So really useful tools in SolidWorks to figure out where maybe some of your bottlenecks are.
Yeah, for sure.
So I don't want to keep you, Toby. I know you have a ton more stuff here. Let's. I'm gonna hand the reins back over and let you.
Yeah, sure. Sure. When you said I don't want to keep you, I thought you were gonna say I know you got a lot to do today, so
No, not
I'll take
at all.
it from here. So we talked in the last example about the idea of how features will dynamically update, based on their dynamic end conditions. A dynamic end condition is something like up to surface or offset from surface or up to next. But what about sketches? Right? Look at this model here. This looks like a pretty complicated model, but if we actually break it down, and before I do break it down, I just want to come up here to my data management in the cloud and make sure that I've got, that I've reserved this file. It's kind of cool. You can see right here, there's a little green key. So it says reserved by me. So now I'm not going to get any of those read-only messages, which is great. That means I can get in here and make some changes, maybe even make a new revision, right?
So Toby, really quick, where are all your files that you're working from? Where are they all right now? Are they on your computer? Like, is this like SolidWorks PDM, or is this somewhere else?
Well, I mean, technically they are on my computer, right? But as far as like a very simplified explanation, no, these are, as soon as I hit save, what's happening is it's pushing up to the cloud. So for example, let's say I made a change to this file. Let's say I change this from 6 instances to 5 instances for the pattern, and then I just press Control S. Well, what you'll see here is that I get this feedback in the task pane, and the feedback is telling me, this little icon here, it's saying the version that you're working on in RAM is different from the version in the cloud. And so what I can do is I can press Control S, just a regular save shortcut, and you're going to see that not only does it save to the temporary local cache, but then it also pushes that up to the cloud. So now the version in the cloud that the whole rest of my team sees is the same as the version I have open in RAM at the moment, and I can tell that by this little green check mark here.
So if you jumped on another computer with SolidWorks connected, you could just access all those files regardless of where you were in the world.
Just grab the file, start working.
That's awesome. Yep. I love it.
So let's take a look at how this model is constructed here. So we can see here that the way that this model is constructed is that it starts out with a revolve, a real simple revolve sketch here to give us the main cover. And then we can see that what we end up with is a center hole right in the top of the model, just a regular cut extrude. And then we have this curved slot. And this is kind of where the magic is happening. In fact, what I think I'll do is I'll just delete everything from that curved slot down so that we can see what's going on in that sketch itself. So the sketch itself here is constructed by creating a curved slot feature. So that's this feature here in the sketch toolbar. So we just come over, we create this kind of curved slot feature. And then what I'm doing with that curved slot feature is I'm creating a tangency relationship here, and I'm creating a linear dimension off center. So right now I just got rid of those two relationships just so you can see what I'm doing. So I'm taking this top arc of the curved slot and I'm making a tangent to this angled line, this bottom arc of the curved slot, and I'm making a tangent to this line. And then I'm creating a linear dimension off center. So I'm coming from center here, off center, to the center of that slot, and let's say I make that 20 millimeters. Pretty straightforward, I think, as far as a sketch goes. But I think kind of what is the magic here is recognizing that I'm not doing a distance here for the center points of that slot. I'm not even necessarily doing an angle of the slot. Instead, what I'm doing is I'm saying I want this to be tangent here, because my goal, what I'm going to be showing you now, is that just like we could have a dynamic relationship in a feature pattern, we can create a dynamic relationship to the sketch relationship. So we've got this slotted hole that we originally created. When we create a pattern, we want it to follow this same tangency relationship, but in a new location. So we want that sketch to dynamically update into the new location for the pattern as well. And this is a bit of functionality known as very sketch when you create a pattern feature. So now at this point, I'm ready to take this fully defined sketch, right mouse button through all, cut extrude that through all, and then I'm going to take that sketch, that feature, I'm going to click on that feature, and I'm going to say I want to create a linear pattern of that feature. Now, when I'm going to create a linear pattern, you'll notice that I don't have an edge that I can select to define the pattern to kind of radiate out from center. But what I do have is a linear dimension, which is going from the origin to this point here. And that point A to point B defines the direction that I actually want for my pattern. So there was a bit of planning or forethought put into how that dimension was created. You know, I could have created it with a radius dimension, right, from the center point, but that wouldn't have worked because then I wouldn't be able to select that dimension here when it comes time to create the actual pattern. So we can see here what I'm doing with this pattern. I'm going to pattern this out. Let's say I'm going to make 5 instances of it, and they're going to be spaced out at 12 millimeters. Yeah, that looks pretty good. And I'm going to hit the green check mark, and all right, that got me close, but not exactly what I wanted. Well, in the linear pattern feature, there's this check mark here called Very Sketch. And when you choose that check mark, that's going to allow the sketch to dynamically update, similar to what we've been describing over the past few minutes. Now, one thing that you should know is that element, that tool won't show up if you pick an edge for your pattern direction. So you notice Very Sketch doesn't show up currently. It won't show up until I pick a dimension from that sketch. So you'll notice here, I'll click on this dimension, this 20 millimeter dimension. Now Very Sketch is available. When that dimension was not selected, you see that Very Sketch is not there. It doesn't show up. So if you try to do this and you pick an edge, you're not going to see it. I'll show you another example of that in just a few moments. So I hit Very Sketch, and you'll notice that the preview goes away. This is kind of thematic, right? When you're creating patterns, take a look at the option for full preview. A lot of times that will show you a preview when you're doing something dynamic. And you can see here that now I can hit the green check mark, and there we go, our nice Very Sketch feature.
So the trick there, Toby, so let's recap. In order to get Very Sketch, so in order to honor all the sketch relationships, the fundamental thing you have to do is you have to pick something from within the sketch you're patterning in order to make the Very Sketch option enabled. Yep. Dimension is probably the best way to do this because a linear dimension defines a linear direction.
You got it. You said it perfect. That's exactly right. And if you don't see that Very Sketch option showing up, that's probably why. And so, now you know that you can create a pattern and have the end condition of the feature dynamically update, but you can also have the sketch relationships dynamically update into the pattern instances. And so you could create something maybe like this. Maybe this is some kind of a drain where you might think that creating this slot pattern across the grate would be very time consuming. But if we look at this sketch of the slot cut itself, so you notice if we go in here and we look at the sketch of the slot cut itself, we can see here that sketch of the slot cut itself is able to be created tangent to this upper region of the model and tangent to this lower region of the model. And that way it follows that curve all the way through. Now, if we're going to get into kind of pro tips here, one little bit of magic that's going on with this particular solution is that I'm utilizing what's called fit spline. Fit spline, as you know, Jeremy, is my favorite feature in SolidWorks.
Yes, it is.
I love fit spline. And so what fit spline lets you do is it lets you take something like a line and an arc and another line here, and it lets you combine them into one single spline. So right now, if I made that slot tangent to this line, it wouldn't really help me because the line only goes a certain distance of the overall pattern length. But what I could do is I could select all those entities and I could go into Tools, Spline Tools, Fit Spline. Now, I've talked a lot about fit spline, and I could probably take the next 30 minutes just to talk about this. I'm not going to, but I do want to share with you that there is a limitation of fit spline that I learned while I was doing this example, and that is you can't seem to create sketch relationships to the fit spline for some reason. So, for example, I can't pick this arc and pick the fit spline and make a tangent. Just not there.
I've never seen that. Yeah,
I've never seen that either. I was very surprised when I ran into it. I can't take this endpoint and make it coincident to the fit spline. Isn't that crazy? You know,
Yeah,
if I drop a regular spline in there, then I'm golden, right? I take this, I can make a tangent all day long. I can take this other point, I can make a coincident, no problem. But with fit spline, I couldn't do that. And so what I ended up doing as a workaround was I just extruded a surface. This is a real common thing that we do when we're trying to find workarounds when splines aren't being nice to us. We can just go in and we can just make a surface, and then I could make a tangent to the edge of that surface. So I think this is so powerful. You know, I just wanted you guys to know if you ever find yourself in this spot, it's something where you can really save a lot of time, but you might need to use that workaround. You know, it didn't take too long once I figured out what the workaround was, and then you're good to go.
Yeah. Hey, Toby, I have a question here from CH35. This probably means something, and I'm not catching it. It says, instead of using the dimension for the direction, could you use a line within the sketch? Would that still give you the option to enable vary sketch?
That's a good question. I don't know the answer to that, and I think that it's kind of a moot point anyway, because when you click on the feature to pattern, the dimensions from that feature show up in the graphics area. So for example, here, you know, let's say I've got this slot sketch, and I've got a line in the slot sketch. So let's say I'm just going to put a horizontal line down here, and I'm going to make that line for construction. So now I'm going to create a linear pattern of that feature. And so I'm going to click down here in features to pattern, and I'm going to click on this feature. You'll notice that the dimensions for that feature show up right away. And so when I go up here to click direction, you know, I can easily just pick on that dimension, and that solves the issue of what direction is it going in, and it solves the issue of the vary sketch option becoming available. Now, in order to do that same thing with an entity from the sketch, I'd probably have to show the sketch first and then go into linear pattern and then pick that feature. And that seems like it would be a bit of extra work, but let's just out of curiosity, let's see what happens. Let's see if vary sketch does show up if I do that. So now I'll go into features here, and I'll pick the slot cut extrude. See, vary sketch still doesn't show up here. It's still grayed out. So it's a good question, but I think you're going to be better off just picking that dimension, because one, you don't have to show the sketch, and two, that's what's going to ultimately allow you to use that vary sketch option. So then in this case, like I said, what I would do is, just so you guys can kind of see this from start to finish, what I would do here is I would indicate the pattern spacing. Maybe here, instead of doing a number of instances, I would just go up to reference. Right, and I could say that I want this to be the reference down on this end, and I don't want it to go all the way up to that reference. I want there to be somewhat of a gap. So maybe I'll make that gap 30 millimeters or 20 millimeters or whatever's appropriate. I'll say I want this to be a number of instances to define that pattern. I'm going to use the option for vary sketch, and hey, look at that, the preview even showed up. So awesome.
So now this is awesome. You've just shown the first thing you showed us combined with this capability.
Yep.
Like, that's really cool. Like the fact that you can mix and match some of these secrets of patterns. Did you hear what I just did there?
I did.
Toby?
Yeah, I mean, that's the whole trick, right? That is the whole trick, is learning how to kind of combine some of these. When you're doing something crazy like this, a crazy pattern like this, you know, you're gonna really want to make sure that you are able to combine some of these different features. So you don't want to sit there and hand calculate what that is, especially if you're still designing that plate and it's still, you know, potentially changing in size.
Yeah. So I have another question from chat, and this is very serious, Toby.
Okay, here we go.
If you were a pattern, what type of pattern would you be?
Oh, man. That's a great question. I'm going to have to think about that one. That's a great question. So let's talk about another example here of vary sketch. And this is one that, like, you might not even think would really be a linear pattern. But I actually got this question once in tech support when I was younger. And the question was, is it possible to do something like this in Solidworks? Right? Is there any kind of a like radiate pattern where you're going to start from the center and you're going to radiate outward, because we're making, you know, couplings that need to go together and need to have gaskets that go in them, something like this? How would you do something like this? And so I thought about it, and I thought back to this example, and I thought to myself, you know what? I wonder if somehow I could use vary sketch and linear pattern to accomplish something similar here. And ultimately, that's the answer. Is that, you know, if you're strategic in the way that you create that cut revolve, you can actually do a ring pattern, a radiated outward ring pattern here, like what we're looking at. So I'm going to delete these two features, and I'm going to just jump into this sketch, and maybe I'll even make a new sketch just so you guys can kind of see the strategy here. So I'm going to go to my right plane, begin a sketch, orient my view, and I'm going to create a small circle here, which is right on the top edge of the model. Let's say I make that 10 millimeters for that circle. And then I'm going to create a a center line that I'm going to revolve that small circle about. So I'm going to create a center line here so that when I go to cut revolve that thing, I've got a center line to revolve about. Now what I'm going to do is I'm going to create a dimension. Now this is where you have to be really strategic, because if you create the dimension to the center line, even if you don't cross over the center line, because you're revolving about that same center line, you're going to get a radius dimension. And what we want is a linear dimension. And so what we'll see here is if we go to features cut revolve right now, and then we double click on this feature, we're going to have a radius dimension here. See, it's radius 60, and it's not a linear, point dimension. Well, we need a point dimension if we're going to do a linear pattern. So the strategy here, and this is kind of interesting, it's actually the opposite of the strategy I usually give people. Usually I tell people, be careful, make sure you dimension to the line, not to one of the endpoints. That way you'll get the double dimension, you'll get the diameter dimension or the radius dimension in your print. Well, here I'm going to use the opposite strategy. I'm going to say dimension to the endpoint rather than dimensioning to the center line. And that's going to leave you with an actual linear dimension that we can use when we go to create our pattern. So you're going to see here that when we go into our cut revolve and we say that we want to create a linear pattern, we're going to be able to click on our direction one, and we're going to be able to click on that linear dimension of 60. And what's happening here is that with very sketch off, we would just be doing a linear pattern like this. So let's say we're going to do this at 5 instances with 12 millimeter spacing. But with very sketch on and full preview on, we can see that what's happening is that SolidWorks is trying to do the linear pattern in this direction, but it's trying to maintain the dynamic sketch relationship from the original cut revolve. And so we end up with these rings.
I just had my mind blown, Toby. That's new to me. I did not know you could do that inside of SolidWorks. So
isn't that so cool? That
is killer. I love it. It's that's such a good tip. I did not know you could do that. Now I have a question here. So when you were talking about dimensioning from the endpoint versus the line, because when you dimension to a center line, it creates a radius or a diameter dimension. Could you have also right-clicked on that dimension and changed it to a linear dimension at that point?
That's a good question. I don't know the answer to that.
Okay. The reason I ask, and I don't mean to give it so many plugs, but again, 2 weeks ago at 3D Experience World, we showed a delighter in the tech preview where they were toggling between radius, diameter, and linear dimensions without having to dig into a right mouse click menu. So this could be brought even more to the forefront in the future potentially.
Yeah, I don't know. I mean, it says here, you got the display options, center dimension displays diameter, show parentheses. If I go over to leaders here.
Yeah, so maybe not.
Yeah, maybe not. Yeah, it's interesting. And it is also dependent on the line that you use to revolve. So that can maybe be another strat would be if you, a strategy would be if you create geometry like this, and then you create a center line, and you dimension to the center line to get the double dimension, or even just to get let's say the radius dimension, because that's what we're talking about here. And then you go to revolve, so features revolve. What happens is that dimension, that sketch is being revolved about the center line, and the double dimension is going to the center line. So the dimension becomes a radius dimension or a diameter dimension. But if you revolved about a different line than you dimension to, then that behavior does not occur. So if I revolved about this line, for example, then that will remain a linear dimension. So, another strat might be to just draw a second center line, dimension to one, and then revolve about the other. But, you're getting pretty nuanced at that point. That's where I thrive, isn't those little nuances, those little percentage of a percentage improvements over time make for huge gains. That's my bag right there.
Yeah, I know we're coming short up on time, but there's a great question in here, and it's something that I think people see us do when we're on video all the time, and that's how are your dimensions just popping up? Do you have an able see all the dimensions on? Why when you select on 3D geometry do your dimensions show up?
I mean, I'm just double clicking really quick. I mean, that's it. If you have instant 3D turned on, then you can
That's what I wanted to show people, was that instant 3D makes it really easy whenever you select on a feature to pull those dimensions up.
Yeah. I mean, my beef with instant 3D is that I always end up relocating planes by accident. So that's kind of why I end up having it turned off. But I mean, everybody I'm not saying it's bad. And there's spots where I have it on. Like I really like the way that it auto updates. Like when I'm looking at the mass of a part and I'm trying to really dial in a mass, having instant 3D on and then just being able to single click and then make a change. Oops, this model's one of my coworkers is working on this model potentially, or they don't know that I'm working on it. So I'm going to right mouse button over here and say reserve. And that way now they know I'm working on it. That's why I was getting those read onlys. The system's like protecting me from accidentally making changes. So now, so now that Instant 3D is on, now I can just single click here and then say I want that to be 75, enter, and it just updates. I don't have to rebuild. Most of the time what I'm doing is I'm double clicking, I'm going to 50, and then I'm control Qing on the keyboard to update it.
So this is a bit of a philosophical question, because I am an instant 3D guy. I like instant 3D when I'm working. You told me you don't. So this is what's great about SolidWorks. Work the way you want.
Yeah, exactly. Yeah. I mean, it's, I think a lot of these tools are situational. People will be like, do you have this turned on? Do you have it turned off? A lot of it's situational, except for Instant 2D. I never have that one on. Shout out to Instant 2D. All right, so here's another. Now we're going to go to our final topic here, which is the vary instances option in a pattern. So we've talked so far about the ability for a regular pattern to dynamically update with your end conditions. We talked about the idea that vary sketch lets you enable a mode where your sketch dynamic relationships will propagate through into your pattern instance results. Now we're going to talk about something really cool called vary instances, instances to vary. And instances to vary shows up down here at the bottom of the property manager, and it allows you to pick different dimensions or even just the vanilla pattern spacing and adjust those independently one instance to the next. And so one scenario where this came up was, hey, is it possible to create a circular pattern but not have equal spacing for all the instances of the circular pattern, almost like a variable circular pattern? And of course, we have a full-blown variable pattern tool, but right within the circular pattern command, we can do this. We can go here to circular pattern. We can say that we want to pattern this lug. We can say that we want to pattern it about this edge of the model. And you can see that by default, this is what we're going to get. We're going to get 3 equally spaced instances. Oops, geometry pattern on was causing me a problem. We're going to get 3 equally spaced instances. Well, what we can do is we can come down here to where it says instances to vary. And with instances to vary, what happens is you get these little magenta dots where you can click on this dot. So this is right at the middle of the instance of the pattern. There's this magenta dot here. And you click on that magenta dot and you say modify instance. And the only parameter that we have indicated that can be modified is the parameter for the location of that instance. So I'm going to say I want that to not be at 120, but I want it to be at 155 degrees. And then I'm going to come down here to this magenta dot and I'm going to say modify instance. And I'm going to say I want it to be at 175 degrees. Maybe that's not a good dimension. So I'm going to say I want this one to be at 220 degrees. Okay, there we go. And so now we can hit the green check mark and you can see that you can have non-uniform spacing when you go to create a circular pattern, for example. Now, this can be taken to another level when it comes to doing a linear pattern, because you can actually do a linear pattern and a revolve in one step. And so this is the camshaft example that I use for the thumbnail for today's session. And I'm going to delete this linear pattern. And actually, before I delete it, you'll notice here, like, I'm getting non-uniform spacing from this linear pattern. This isn't instances to skip. I'm not going in and using instances to skip. What I'm doing is I'm saying I want the distance between these instances of the pattern to vary, to be different from one instance to the next. Beyond that, I'm also going in and saying I want the rotational angle to change for that cam as it goes up through the pattern, all in one single linear pattern. So the way that we can do that is we can say that we want to create a sketch of the cam using a dimension for the angle. So here's this dimension for the angle. So I've got this 90-degree angle on the horizontal, what would be the horizontal location of the cam. In other words, if I change this to 45, you can see that the angle of the cam changes. This dialog box is pretty wide from doing those equations. If I change this to 90, you can see that the location of the cam changes there. So that is key make sure you give yourself a dimension that you can adjust. This kind of harkens back to when you're using design library. It's good to create kind of an anchor point and then an angle dimension rather than using vertical and horizontal. That's going to be the same thing here. If you're trying to do a linear pattern and incorporate revolve into the linear pattern, this is definitely going to be helpful to have a angle dimension in your sketch. So I'm going to now choose to perform a linear pattern command. For the direction of the linear pattern, I can actually choose this cylinder here, which is kind of cool. It picks up on the axis of that cylinder. For the feature to pattern, I'm going to choose this feature here. Here you can see that for the spacing of the pattern, I'm going to say that I want the spacing to be, maybe a little bit more, and I'm going to say there's the number of instances. And then down here where it says instances to vary, well, we talked a moment ago about how I can click on any one of these and I can change their the spacing, right? But what I can also do is I can come down into this dialog box here where it says choose feature dimensions to vary in direction 1. All right, well, what dimensions do I want to vary? I want to vary this angle dimension here, this 90 degrees. And what I can now do is for any of these instances, I can choose to change that 90 degrees. But what's even cooler is that I can actually do that overall at an incremental value. So I could say I want that change to be 30 degrees per instance. And if I click here on full preview, you can see that now what I'm giving myself is a spiral staircase in one single linear pattern command at the feature level.
That's pretty powerful by itself right there, is that you're just that ability to change that rotation. But you also showed the spacing between the instances too, right?
You do the spacing between the instances. You could do, really any dimension that you have in that sketch, or the spacing from the feature pattern as well. Like in this case, this linear pattern here of the holes. So this corner hole pattern here in that grade example, what this is doing is it's doing a modify instance on this instance of the hole here, where what I'm doing is I'm changing the diameter of that hole. So there's a sketch dimension for the diameter of the hole. I'm changing the diameter, and I'm also tightening up the spacing just a little bit on that last one. So I'm modifying the spacing, and I'm modifying, what would you have to do otherwise? You would create this pattern, and then you would go in and make one additional cut extrude where you'd manually put in those dimensions. You don't have to do that. You can just do it all in one feature pattern.
Man,
so I think that's pretty much it, Jeremy. What do you think?
I love it. There was so much cool stuff here for me to I got to sit back, hang out with you, Toby. I learned some new stuff today, which is always great. I always want to do that. You haven't answered the question, Toby. If you were a pattern, what kind of pattern would you be?
I think I'm a man of consistency, Jeremy, so I'm just going to stick with flat pattern. That's my go-to.
Yeah. So I want to thank everybody in the chat for tuning in today.
Maybe we should ask the chat, right? We guys, if you enjoyed this, we talked about basically like nuances, secrets of patterns. But if you want to see more about patterns, maybe later this season, give us a 1 in the chat. Because I'm sure that Jeremy and I could do something. Maybe we could reverse roles, Jeremy. Maybe I can host and you can be the speaker.
You actually mentioned something at the very end that gave me an idea for what I would like to present. I want to do a cool thing I want to do something on library features, actually, I think.
Oh, man, I love library features, too. So powerful, It's like it takes a little bit of time, maybe say a few hours to learn library features, to really learn the kind of like nitty gritty. And then like hundreds and hundreds of hours that you can save by learning how to leverage them. Yeah, love library features.
So again, I want to thank everybody for tuning in. We're kind of here at the top of the hour. I want to remind everybody, we're going to be doing this every other Thursday on YouTube. We also have next week through Thursday, you can tune into our YouTube channel and you can watch John and Gian covering exploring 3D experience work. So if you liked what Toby showed here today, he was kind of connected. He was using SolidWorks connected to the 3D experience platform. They're going to go into more detail on 3D experience works, whether that's some CAD in the cloud tools or other capabilities there. Then in 2 weeks, we're going to have Michael Steves on SolidWorks Live Design. He is going to be covering some simulation capabilities. So that's always a fan favorite. They want to know how to do simulation, renderings. We've definitely changed the format for live design moving forward so we can cover a lot more tools with things like this. So I really encourage
Nice.
you. Yeah, we're going to have a ton of stuff. If you haven't yet, hit the subscribe button on the YouTube channel and click the bell notification icon. We're going to try to come on a few minutes early every week, chat like me and Toby did at the beginning of the day while we get warmed up, and then kind of kick it right off at 11 a.m. Eastern time.
Yeah, and if you guys are bored this weekend on Saturday at 1500 GMT, which is 10 o'clock East Coast for me. But on Saturdays, I host a live stream too, where I do some like tips and tricks and modeling challenges as well. So if you guys are bored this weekend, or even if you're not bored, if you just want to hang out with like one of the most amazing chats out there, feel free to tune in on Saturday as well. That's over on the Too Tall Toby stuff.
Yeah, and if you're watching this after the live stream, go ahead, put put in the comments what you'd like to see us cover on SolidWorks Live Design. We're always looking for cool ideas. Maybe you want to see more patterns. Maybe somebody wants to see some cool weldment tricks.
I saw Mike Savocek said assembly patterns. I know you've got that amazing engine assembly. I think he would love seeing that.
Yeah, we could do some fun stuff with that. Show how to get a timing chain to work properly on there, maybe.
Yeah, I like the sound of that. That's what gets me excited.
All right. Well, Toby, as always, thank you. You rocked today. You showed us, the audience, some really cool stuff. I want to thank you for joining. And to the audience, thank you for joining us today. I want to encourage you to tune back in next Thursday. And with that, I think we're going to sign off here. I think somebody behind the scenes is going to hit the stop button.
All right, Jeremy. Great job today, man. Great to kick off the season with you.
Yeah.
All right, cool. See ya.
See ya.